So let's look at this problem here, this example from our notes or for our lecture. And the instructions say we want to rewrite these expressions using a single exponent. So just goes back to now, without using rules of exponents, this just goes back to, let's go back to the definition. 2 to the power 3 times 2 to the power 4. It's a multiplication of two separate expressions, and so what I have is 2 to the power 3 means 2 times 2 times 2. 2 to the power of 4, let's put it in a different color. 2 to the power of 4 means 2 times 2 times 2 times 2. And so we were going to do this in a long way. What this is 2 times 2 times 2 times, and then you do 2 times 2. So this is how you would do it if you didn't know the laws of exponents and just knew the definition of what we're dealing with here. And so in the end, 2 to the power 3 times 2 to the power 4 is equal to 2 to the power of, and you count 1, 2, 3, 4, 5, 6, 7 all together. There are 3 plus 4 equals 7 factors. 7 factors of 2, and so that's why this answer is 2 to the power of 7. And so then when you look at this one here, we can then say that that would be equal to 3 times 3 times 3 times 3. That's going to be 5 times. 3 times 3 times 3. That's 5, 6, 7. And so then in the end, you can then see why here we would get 3 to the power 12. And so as you do those calculations, what emerges again is a question, a pattern. You're saying, you know what? Every time I multiply numbers that have the same base, it looks like I can just add the exponents instead of writing all of this out. We see the pattern, right? So in this case, a pattern emerges, and then we ask, is it true always that when we do this situation, right? When we have a number, a base, let's say it's the n, times, is it true? Would that always be true? And we know it is from our algebra experiences that it is, but it emerges from these patterns that we exist here. So that leads us to our first rule of exponent or theorem here, that a to the power of m times a to the power of n is equal to m plus n. And ignore that I changed it, right? So it's n plus m or n, however you write that. It doesn't matter in the end. But again, what emerges is that you end up adding those exponents, right? And then so this is just a theorem in mathematics which can be proved, right? We can, it's a statement that can be proved, and here's the proof. A to the power of m is a times a times a, and if you look carefully here, that would be m factors and then n factors. And so what happens is you have a m plus n times, or n m plus n factors. And so there's a proof of that one there.